Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, and the same chapter, that is chapter number 22. So in the last class we have started with part number 7, that is the spatial databases, and in the last class we also started with the chapter number 22, that is a combination of, that is the object oriented model, that is the combination of the object based databases. So let's take a quick review what we have covered in the last class, then move to today's topic, that is the today's scenario, that is chapter number 22. Next version of the, or next week, is the few topics of the chapter number 22. So part number 7 is speciality or special databases, that is what are the special databases that is available in the database management system. So several database or several application areas for database systems are limited by the restrictions of the relational data model. So whatever the relational model, whatever the databases that are concerned, that are limited by the restrictions of the relational data model. And as a result, researchers have developed several data model based on the object-oriented approach to deal with these application domains. That is, everything is contextual, everything is remain conceptual, that is deal with the object-oriented method, that is deal with the database object-oriented method, that is the object-oriented approach. We have studied, or we are going to study in the chapter number 24, that is object relational model, and what are the various methods that is used in the object relation model. That applies the inheritance to the relation along with the usage of the described to database system that directly access the database management system. Now we have also already discussed, or also discussed chapter number 22, that is the object based databases, that is what is object based databases, how to use the object based databases, and what are the various scenarios, what are the various criteria to be used with the object based databases. So traditional database application that consists of data processing application, that consists of data processing tasks such as the banking and the payroll systems or payroll management, with the relatively simple data type that is used, that are well suited to the relational data type. So what are the data types? Whatever the data type that is used, that database application possess the task, for example the banking and the payroll management. As database systems were applied to a wider range of applications such as the computer-aided design and the geographical applications, the object-oriented model or object-oriented or object-based databases make the database or perfect the database or do the database perfectual by giving the graphical information that is immersed, that is done by the object-based databases, which allows one to deal with the complex data type, that is one is dealing with the complex data type that is available in the object-based databases. Then overview of the object-based databases that is used. So we are using the relational database model that are limited by the object-oriented model, that is also uses the facilities or support the ER model and the extended ER model that has to be translated to the simple or simpler SQL data types. The object relational data model extends the relational data model by providing a richer type system, including the complex database system, including the data system that is available, that is also includes in the database management system. So relational query languages, in particular SQL, need to be correspondingly dealt with the rich type system that is used with the object relational database model. And the database model that is used, that is the object relational model, that provides a convenient migration for the users of the relational database who used to use or who wish to use object relation features. And the second obstacle, or we can say the second difficulty that is faced, or that is in accessing the database from the program written in languages such as C or ++ or Java. And there is a SQL, that is a query language that is used to gain the database's object-oriented features. Then we have also discussed about the issues of supporting the persistence for the data that is in the native type of the or native type system of the object-oriented programming language. And two approaches that is used in this respect is object-oriented database system, that is a database system that natively supports an object-oriented type system, then allows the direct access to data from an object-oriented programming language using the native type system of the language, and automatically converts the data from the native type system of the programming language to a relational data representation and vice versa. So whatever the representation, whatever the data that is available, that is represented by the programming language that is available in the relational representation. And data conversion is specified using an object relational mapping. So whatever the content, whatever the relational object oriented mapping that is used with the object relational mapping. And we provide a brief introduction to both these approaches that is available in the object-oriented database system and the object-relational mapping. Then finally, we outline the conditions in which the object-relational approach is better than the object-oriented approach. So this is a comparison between the object-relational approach, in which the relations are maintained, in which the tables are maintained, and the object-oriented approach, in which the everything is available, everything is possible, every operation is done on the object-oriented approach. Then we also talked about the complex data type, that is what is a complex data type and how to use the complex data type that is available in the object relational or object oriented model. Traditionally, database system are conceptually simple data type that is used, and the basic data item that is stored that are relatively small, and the fields are also atomic, that is there are no structure that is used in that atomic data type. And in the recent years that is used, demand has grown for a ways to deal with the more complex data type, that is a more and more complex data type is available in the database management system, and with the entire address that could be viewed as an atomic data type of item string. On the other end, if the address were represented by breaking into the component like street address, city name, postal address, writing the queries, a better approach is to use the structured data type, that is allow a type address that also support the relatively data types. Then we also talked about the structured type and the inheritance in the SQL, that is how to use the, or what is the meaning of structured type and what is the use of inheritance, that is how to use the inheritance, that is one object is derived from another object, that is also used in the SQL, that is structured type and the inheritance in the SQL. So SQL type system consists of a fairly simple set of predefined types that is also used, that have one different option that have structured types and the type inheritance. So first is the structure type that allows the composite attributes of EI design to be represented directly. For example, we can define the following structure type to represent a composite attribute, that is a name, with component attribute, that is the first name and the last name. Structure type means that it is divided into two parts, that is the first name and the last name. So create a type, so that means creating any type, that is the first name and then the first name and the last name, that is also used, and also created the address, and that contains three fields, that is street, city and the zip code, and then created the table, that is a person, that contains the name, address and date of birth at the date. An alternative way of defining the composite attributes in SQL is to use the unknown named row types. For example, the relation representing person information or personal information could have been created using the row type as follows. So this is also used using the row type, that is as follows, that is create a table person R, then name a row, and the first name varchar 20, address row, street varchar 20, city varchar 20, zip code varchar 9, and date of birth date. And this definition is equivalent to the preceding table definition, except that the names or attribute, that is the name and the address, have unnamed type, and the rows are also have unnamed type. The following query illustrates how to access the component attributes of a composite attribute, that is select the name dot last name address city from the table person. Then is the type inheritance. We also discussed, that is how to create the type inheritance, that is how one type will be derived from the another type, that is a type inheritance. So this is create the type person, that contains two fields, that is the name and the address. Name is of varchar type and the address is also of the varchar type. Now again creating the type, that is student, that is under the person, that is all the attributes of a person is inherited by the student, that is under the person. Then also contain two parts, that is the degree and the departments. The degree is also varchar and the department is also of the varchar. Then create the type teacher, that is under the person, then salary integer department varchar. And both the student and the teacher inherit the attributes of the person, namely demand, address and teacher, that are said to be the subtype of the person, and the person is the supertype of a student. And there will be inheritance that also support the multiple inheritance, that is also used. This is create the type teaching assistant under the student and the teacher, and teacher assistant inherit all the properties of the teaching inherit all the properties of the student and the teacher. So whatever the properties of the whatever the attributes of the student, the teacher, that is inherited by the teacher assistants. Next is the table inheritance, that is the today's topic, that is how to inherit the full table, that is the table inheritance. So the next topic is table inheritance, that is the today's topic, that is how to inherit the full table, how to inherit the full relation, that is the table inheritance. So subtables in SQL correspond to the ER notation or ER notion of a specialization generalization. For example, suppose we define the people table as follows. So this is the people table that is defined, that is a create table people of person. So whatever the table that is created, that is the people, that is of the person. We can then define the table, that is the student and the teachers, as subtable of the people. So we can also define the table, that is the student and the teachers, as a subtable of the people. So first of all, define the table or create the table, that is the people, that is a person, that is a person is a relation, or we can say the person is the type that is used. Then we can define the table student and the teachers as the subtable of the people as follows. This is the criteria, that is how to define the tables, that is the student and the teacher as a subtable of the people. Now this is the scenario, this is the condition that is used, that is the create table students of student under people. So create the table students of the student under the enter the table people, that is inherit the properties of the table student people. Then create the table teachers of teacher under people. The types of the subtable, that is student and the teacher, in the above example are the subtype of the type of the parent table, that is the person in the above example. As a result, every attribute present in the table people is also present in the subtables, that is the student and the teacher. So whatever the attributes, that is the every attribute that is present in the table people, that is also present in the subtables student and the teacher. So it inherits that the student and the teacher's table inherit the properties of the people also, or inherit the properties of the table, that is the people also. Further, when we declare the student and the teacher as subtable of the people, every tuple that is present in that student or teachers become implicitly present in the people. So whatever the table, whatever the student and the teacher declare as a subtable of the people, every tuple present in the student or the teacher becomes implicitly present in the people. Therefore, if a query uses the table people, it will find not only the tuple directly inserted into that table, but also the tuple that is inserted into the subtable, that is the names, and or that is a table that is student and the teacher. So whatever the teacher, whatever the tuples, whatever the table that is used, that will not only contain the tuple that is directly inserted into the table, but also the tuple that is inserted into the subtable, that is a table name is student and the teacher. However, only those attributes that are present in the people can be accessed by that query. So whatever the query, whatever the attribute that is used, that is present in the people, that can be accessed by that query. SQL permits us to find the tuples that are in people but are not in the subtable by using only people in place of people in a query. So whatever the query that is used, whatever the table that is used, so to find the tuples in a people that are in a people, not in the subtable, so we use the term that is the only people in place of the people in a query. The only keyword can be used in delete and update information. That is the only means only find the value in a specified table, only find the value in a specified manner. So with the only student, or with the only keyword delete statement on the subtable, such as the people, the deleted also delete the tuple that were originally inserted in the subtable. For example, delete from the people where p, that is delete from the table, delete from the relation people, that is where the p is the condition. So it will delete all the tuples from the table people as well as its subtables, that is the student and the teachers that satisfy the p. If the only keyword is added to the above statement, that is if the only keyword that is also added, or only keyword that is added to the above statement that is used, the tuples that were inserted in the subtables are not affected. That is the whatever the tuples, whatever the relation that is used, that is not affected even if they satisfy the where clause condition. That is the where clause condition is also satisfied with the where clause condition. Subsequent queries on the super table will continue to find these tuples. So whatever the queries, whatever the super table that is used to find the queries on the subtables. Conceptually, multiple inheritance is possible with the table, that just as it is possible with the types. For example, we can create a table of the type teaching assistant. This is the table that is created, that is the teaching assistant of the teaching assistant, that is under the student and the teacher. So this inherits the properties of both the table, that is the student and the teachers. As a result of the declaration, every tuple that is present in the teaching assistant table is also implicitly present in the teacher. So whatever the tuple, whatever the rows that is available in the teaching assistant, that is also available in the teachers and in the student table, and in turn in the people table. We note that, however, that multiple inheritance of tables is not supported by the SQL. So whatever the multiple inheritance that is not supported by the SQL, that is not supported by the SQL language. There are some inconsistency requirements for the subtables. Before we state the constraint, we need a definition, we need a method that will do or that will say that the tuples in a subtable and the parent table correspond if they have the same values for all the inherited attributes. Therefore, the corresponding tuples represent the same entity. That is, the corresponding tuple means the same tuple have represent the same entity that is available in the corresponding table. The consistency requirements for subtables are as follows. So what is the consistency requirement? That is, each tuple of the super table can correspond to at most one tuple in each of its immediate subtable. That is, every tuple that is available in the super table then correspond or that can correspond to at most one table or one tuple in each of the immediate subtables. Then next, SQL has an additional constraint that all the tuples correspond to each other must be derived from other or from one tuple. That is, the SQL also have also constraint, additional constraint, that every tuple that is correspond to other constraint or that is correspond to that is related to other constraint that must be derived from one tuple that is inserted into the table. For example, without using the first condition, we could have the tuples in the student or the teacher that correspond to the same person. The second condition rules out a tuple in a people correspond to both a student or tuple in a student and tuple in a teacher, regardless of the tuple that is implicitly used that will inserted in a table that is a teaching assistant, that is a subtable of the table that is the teachers and the student. In other words, we can create our own improved implementation of the subtable mechanism using the existing features of the SQL. So we can also improve our implementation of subtable mechanism. So we can also maintain the subtable. We can also create the subtable by using the existing features of the SQL with extra or some extra efforts in defining the table. And we note that SQL defines a privilege known as the under. So SQL also defines a privilege that is the under, which is required in order to create a subtype or subtable under another table or type. The motivation of this privilege is similar to that for the references privilege. So whatever the motivation, whatever the privilege that is used, that is similar for that of the references privilege that is used in the motivation that is used in the privilege table. Now next is the array and the multiset types in the SQL. That is, what are the arrays and how to use the multiset types in the SQL. So array means a collection of homogeneous we can say the homogeneous items, that is similar items are grouped together in an array. So SQL supports two collection types, that is the arrays and the multisets. So whatever the two collection type that is available that contains the arrays and the multisets, that is array types were added in the SQL 1999 while multiset were added in the SQL 2003. That is a single set, or we can say the array set is available from the year 1999 and the multiset types are added in the from the year that is the 2003. And multiset is an unordered collection where the element may occur multiple times, that is the same element may occur multiple times or more than one times. Multisets are like sets except that the set allows each element to occur at most once. That is, these are like the sets, that is, these are like the group, but the condition is that each set allows each element or the set allows each element to occur at most once. Suppose we wish to record information about the books, including a set of keywords for each book. Suppose also that we wish to store the names of the author of a book as an array. Unlike elements in a multiset, the elements of an array are ordered. So whatever the content, whatever the ordered information that includes the keyword for the array, that includes the keyword for each book, and each book has contained or multiple books, or each book contain multiple keyword that is used to record the information about the array. Suppose also that we wish to store the names of the author of a book as an array. Unlike elements in a multiset, the elements of an array are ordered. So there is a differentiate between the first author from the second author and the so on. So there is a differentiate between the books and the author name, that is the first author, second author, and the so on. The following example illustrates how these arrays and multiset values attributes can be defined in the SQL. That is how these arrays, how the array elements, how the multiset element attributes can be defined in the SQL. So first is create the type publisher. So create the type, that is name of the type is the publisher, that is used as an array name and the branch, and the name is of varchar type, that is of 20 characters length, and the branch is also of the varchar type, that is of the 20 characters length. Then again create a type that is a book. So there are two types that is created, one is a publisher, one is a book, and the book also contains the various fields like title, that is of varchar, that is of 20 characters, then author array, that is of varchar, that is of 20 characters, And then publisher date, that is a date format. So varchar means we can also combine the characters, we can also combine the features, we can also combine the numeric values. Then publication date, that is the publisher date. Then publisher, that is the name of the publisher, that is a publisher type. Then keyword set varchar 20 multi-set. Then create the table books of book, that is a create a table, new table, that is the name of the table is books, and that is created of the type book. The first statement defines a type called publisher with two components, that is a name and a branch. The second statement defines the structure type book that contains a title, author array, and which is an array of 10 author names. So book is an array that is contain 10 authors names and a publication date, publisher, and a multi-set of keywords. Finally, a table books containing a tuples of type book is created. So this is book is created, that is of the type book. Note that we used an array instead of multiset to store the names of the authors, since the ordering of author generally have some significance. So we can use the multiset order, we can use the multiset array to store the names of the author, since the ordering of the author generally have some significance, whereas we believe that the ordering of keyword associated with the book is not significant. In general, multi-valued attributes from an ER schema can be mapped to a multi-set valued attributes in SQL. So whatever the multi-set attribute that is used from the ER schema, that can also be mapped to the multi-set value attribute in the SQL. If the ordering is important, SQL array can be used instead of multi-set. Now next is creating and accessing the collection value. So whatever the collection value, whatever the array element that is used, that is collecting the data element, that is creating and accessing the collection values. So an array of values can be created in SQL 1999 in this way. So whatever the array of value that can be created, that is created in this way, that is the array. Then silver chats, then course, then Sudarshan. That is the name of the book. Then the name of the author, name of the book, then the author or the title. Then there will be a name of the author, Sudarshan. Similarly, a multi-set of keyword can be constructed as follows. That is a multi-set computer database SQL. Therefore, we can create a tuple of the type defined by the books relation as follows. This is a book that is created, that is a compilers, array, new, publisher, then there will be a multi-set. Here we have created a value for the attribute publisher by invoking a constructor function for the publisher with appropriate argument. So whatever the publisher, whatever the we can say the content, whatever the attribute that is used, that is available with the appropriate arguments. Note that this constructor for publisher must be created explicitly and is not present by default. It can be declared just like the constructor for the name, which we saw earlier in section 22.3. Then if we want to insert the preceding tuple into the relation books, we would execute the statement. So whenever we created the preceding tuple that is used in the relation books, we could execute the statement, that is insert into the books, that is inserting into the books, then values, then compilers array Smith Jones. So this is inserting, that is insert the values into the books. Then what are the value that is used, that is the compilers, then array, that is a Smith and the Jones, then new publisher, that is a McGraw-Hill, New York, then multi-set, that is a parsing analysis. So these are the various values, these are the various books, that is whatever the content, these are the fields in which the array will be, or these are the content in which the content will be added. So we can access or update the elements of an array by specifying the array index, for example author array 1. Next is querying collection valued attributes, that is how to query the collection value attribute. So we can consider how to handle collection value attribute in queries. As an expression evaluating to a collection can appear anywhere that a relation name may appear, such as in a from clause, as the following paragraph illustrate. We use the table books that we defined earlier. And if we want to find all the books that have the word database as one of their keyword, use the query. So one of the keyword that is used the query. Then the select title from the books where the database name that is used. Now next is nesting and the unnesting, that is how to use the nesting value, that is how to maintain the nesting value, and how to use the nesting value, that is the nesting and the unnesting. Nesting means create one nesting, that is the one relation within the another relation. Unnesting means again creating the one relation out of the multiple relations, that is the unnesting. So transformation of a nested relation into a form with fewer relation value attribute, that is known as the unnesting. The books relation has two attributes, that is the author array and the keyword set. That is the collection, and the two attribute that is also used, that is the title and the publisher, that are not. Suppose that we want to convert the relation into a single flat relation with no nested relations or structure types at attributes. So whatever the structure type, whatever the relation that is used, that is created with the relation structure attributes. We can use the following query to carry out the task. So this is the title, then author, publisher name, publisher branch, then keyword. So these are the 5 fields that is used. These are the 5 content or 5 column heading that is used with the table, or that is used with the attributes. Then the title is compilers, author is Smith, and the publication name is McCall Hill, publication branch is New York, and the keyword is parsing. Again the title, next title, then again the next title. These are the various title that is used. And this is the result of the flat books, that is the result of the unnesting attribute, that is the author array and the keyword set of the relation books. This is the select title, a dot author, publisher dot name as publisher name, publisher branch as public branch, and the k keyword. The variables b in the form or in the from clause is declared to range over the books. So whatever the range, whatever the value that is used, that is declared to range over the books. The variable a is declared to range over the authors in author array for the book b, and k is declared to range over the keyword in the keyword set. Note that the relation flat books is in 1NF, since all its attributes are atomic values. So whatever the atomic value, whatever the content that is available in the flat books is in the first NF, that is the first normal form. So the reverse process of transferring one NF relation into nested relation is known as the nesting. So whenever we convert the one NF, that is a single form, or single, we can say the normal one relation, one function, or we can say the one table that is defined into multiple table, or that is divided into multiple table to delete the inconsistency, to delete the duplication, to remove the redundant data, that is known as the nesting. And nesting can be carried out by extension of a grouping in the SQL. In the normal use of grouping in SQL, a temporary multi-set relation is created for each group. So whatever the creation, whatever the restriction that is used, that is created for each group, and an aggregation function is applied to temporary relation to get atomic value. The following queries nest the relation on the attributes keyword. That is also used to define the keyword, that is a select title, author, publisher as publisher, then collect keyword as a keyword set from the flat books, that is grouped by the title, author, and the publisher, that is grouped by the 3 fields, that is the title, that is the author, that is the publisher. The result of the query that is also available on the flat books relation, that is also available in the figure 22.3 appear in the 22.4. That is the publisher. This contains the 2 part, that is the nesting part, that is the publisher and the publisher branch. This is the name of the publisher, and this is the branch of the publisher or publication. This is the publication name, publication branch. So a partially nested version of the flat books relation. Then this is the select title, then collect author as the author set, then publisher, public name or publisher name, publisher branch as publisher, then collect the keyword as keyword set from the flat tables or from the flat books, that is grouped by the title and the publisher, that is grouped by the 2 fields, that is the title and the publisher. Another approach to creating nested relations is to use subqueries in the select clause. So whatever the select clause that is used, that is used to nesting the query, that is used to use the queries in the select clause. An advantage of the subquery approach is that an order by clause can be used in the subquery to generate results in the order desired for the creation of an array. So whatever the creation of an array, whatever the content that is used, whatever the result that is used, that is done by the order by the clause. The following query illustrates this approach. The keyword array and the multiset specify that an array and a multiset to be created from the results of the subquery. This is a select title, then array, then select author from the authors as A, where A dot title equals to B dot title, then order by A position from the keywords as a K. The system executes the nested subqueries in the select clause for each tuple generated by the from and the where clause. So there are 2 clauses, there are 3 clauses that is used. That is the select clause, that is the from clause, and there is the where clause. Observe that the attributes beat or title from the outer query is used in the nested queries to ensure that only the correct set of authors and the keywords are generated for each title. And the SQL 2003 provides a variety of operators on the multi-sites, including a function settemp that returns a duplicate-free version of the value, that is the interaction between the values. Next is the object identity and the reference types in the SQL. That is how to use the or how to maintain the object identity. What is the main target between among the object identity and the reference types in the SQL. So object-oriented languages also provides a facility to refer to the object. This is a privilege that is available in the object-oriented method that is to use or that provides the facility to refer to the object. So we can refer to any object that is used in the object-oriented language. An attribute of a type can be referenced to an object of specified type. For example, in the SQL, we can define a type department with a field name and with a field head that is reference of the type person, and the table departments of the type department as follows. So whatever the content, whatever the type that is used, that is the department that will be used or that is reference to the type person. So this is the example that is used to create a type department. So one type will be created, that is a department type, that contains fields that contain attributes like name, that is of varchar type, that is a varchar 20, and head, that is a reference by the person, and then scope is people. Then create a table departments of the department. So this type will be defined first of all, that is a create the type department, and then create a table departments of the type department. That is every type, that is every field, that is every relation, that is every field name is available within the type or with the same type, that is a department. Here the reference is restricted to the tuples of the table people. The restriction of the scope of a reference to the tuple of a table is mandatory in the SQL, and it makes references behave like foreign keys. That is the reference will be available, that is the references will be made in the foreign key that will be used in the foreign value. We can omit the declaration, we can omit the declaration scope people from the type declaration, and instead makes an addition to the table create table statement. This is create the table departments of the department and then head with option scope people. This referenced table will have an attribute that stores the identifier of the tuple, and we can declare this attribute known as a self-referential or self-referential attributes by adding a self-references clause to the create table statement. This is the create table people of the person, that is reference is person ID, that is the system generated. Here the person ID is an attribute name, not a keyword, and the create table statement specifies that the identifier is generated automatically by the database. This is the one of the example that is used, that is insert into departments cs null, then update department, that set head equals to select p dot person id people as p, where the name equals to John, where the name is equal to cs. Then alternative that is used with the system generated identifier is to allow users to generate the identifier. And this is the user generated method that is used, that is create the type person, then name varchar 20, then address varchar 20, then reference using the varchar 20. Then create the table people of person, that is reference is person id user generated. Then next is the implementation of OR feature, that is how to implement the object relational database feature, that is implementing the OR features. So the object relational database systems are basically extensions to existing databases that is used or relational system that is used. Changes are clearly required at any or at many levels of the database. So changes are maintained or required at many levels of the database system. So there are many levels in which the changes are very much required. So however, to maximize or minimize the changes to the storage system code, the complex data type supported by the object relational system can be translated to the simpler type system of the relational database. That is whatever the complex data type that is available in the object relational system, that can be translated into the simpler type system of the relation database. And to understand how to do this transaction or how to do this translation, we need to look only at how features of the ER model are translated into the relation. So whatever the relation, whatever the data that will be available, that will be translated into the relations. For example, multi-valued attributes in the ER diagram or ER model correspond to the multi-set attribute in the object-oriented or object relational model. and the subtables can be stored in an efficient manner without the replication of all inherited fields. So whatever the inherited field that is available, so subtable can be stored in an efficient manner, in an we can say the perfect manner, without replication, without doing the replication, without doing the duplication, in one of the two ways. So these are the various ways in which the replication is not the replication is required in the inherited field. Each table first way is that each table stores the primary key which may be inherited from the parent table and the attributes that are defined locally. Inherited attributes do not need to be stored and can be derived by means of the joins with the subtable. So whatever the subtable, whatever the join that will be used, that is on the basis of the primary key. Then each table stores all the inherited and locally defined attributes, and when a tuple is inserted, it is stored only in the table in which it is inserted, and its presence is inferred in each of the super tables. So whatever the super table, whatever the relation that is used, that is available in the relation that is available in the data type that is used. Implementation may choose to represent array and the multiset type directly, or may choose to use an normalized representation manually. Normalized representations tend to make more space and requires an extra join grouping cost to collect data in an array or multiset. And whatever the data, whatever the normalized way that will be represented by, that is easier to represent or easier to implement. Then the ODBC and the JDBC application program also have been extended to retrieve and store structured types, and JDBC provides a method that is a get object that is similar to the get string method, but returns a Java struct object from which the components of the Java structure type can be extracted. And it is also possible to restrict or associate a Java class with an SQL structure type, and JDBC will then convert between the types. See the JDBC reference for the details. So these are reference for the details. Now next is the persistent programming interface. That is the important topic that I'm going to take after the break. So let's take a break right now. That is after the break, then we are doing the persistent programming languages. So let's take a break. Let's come back from the break. Now let's have a session again. So the next topic is persistent programming languages. Persistent programming languages, that is what are the various persistent programming languages that will be used in the SQL, that will be used in the objective relation model or the object database model. So database languages differ from the traditional languages that is used, that can they can directly manipulate the data that are persistent. So automatically they can manipulate the data, automatically they can relate the data, they can hire the data, they can manipulate the data that are very persistent, that is they are very constant, that are constant data, that is the data can continue to exist even after the program has created it has terminated, or the whatever the program that is used, whatever the termination that is used, that the uses the program that is created in a terminated manner. A relation in a database and a tuple in a relation are examples of the persistent data. So whatever the data, whatever the relation that will be available in the database, whatever the tuples that is used in the relation, that are an example of the persistent data. In contrast, the only persistent data that traditional programming languages directly manipulate are file. So whatever the persistent data, whatever the programming languages, whatever the traditional programming languages that directly manipulates are the file. So the persistent data, that is the constant data that is used to manipulate the file, that is used to manipulate the programming languages, that is the files. Access to the database is only one component of any real world application. So whatever the application, whatever the access to the database, that is only the one component that is also used for the real world situation. While data manipulation languages like SQL is quite effective for accessing the data, a programming language is required to implementing or for implementing other components of an application, such as a user interface or communication with other computer. So whatever the programming, whatever the language that is used, that is required to implement the other components of the application, such as a user interface or communication with the other computer. The traditional way of interfacing database languages to programming languages is by embedding the SQL within the programming language. So the main motto or the traditional method that is used to use the, or that is have the used database application is to use the programming languages, is to embed the SQL or embedding the SQL language within the programming language. So embedding SQL language within the programming language, that is a connectivity between the SQL and the programming language, that is a traditional approach in making the SQL very effective. A persistent programming language is a programming language that is extended with construct to handle the persistent data. So it's a programming language that will be extended with the construct. So we can use the extend, or we can use the construct with the extended form to handle the persistent data. Persistent programming languages can be differentiated from other languages with embedded SQL in at least two ways. So these languages are different from the other languages in two ways. What are the two ways? So first of all, with an embedded language, the type system of the host language usually differ from the type system of the data manipulation language. So the type system of the host language will be different from the type system of the data manipulation language. The programmer is responsible for any type conversions between the host language and the SQL. So the programmer is responsible, that is how to use the type conversion or how to convert the files between the host language and the SQL. Having the programmer carry out this class has several drawbacks. So these are the drawbacks that is will be used. The code to convert between objects and tuple operates outside the object-oriented type system and hence a higher chance of having undetected error. So whatever the code that will be used to convert between the objects and the tuples that operates outside the object-oriented type system and hence a higher chance of having undetected errors. Conversion between the object-oriented format and the relational format of the tuples in the database takes a substantial amount of code. So whatever the data that is will be used, that is related with the substantial amount of the code. The format translation code that is used with the code for loading and unloading data from a database can form a significant percentage of total code. So whatever the total code, whatever the percentage that is used, that is received by using the total code for an application. In contrast, in persistent programming language, the query language is fully integrated with the host language. So whatever the query language that is integrated with the host language that use or that share some value, that share some data in having the database management systems. Second, the programmer uses an embedded query language is responsible for writing explicit code to fetch data from a database into the memory. So whatever the programmer that is used, whatever the embedded query language that is used, that is responsible for writing the explicit code to fetch data from a database into the memory. If any updates are performed, the programmer must write code explicitly to store the updated data back in the database. So whatever the updation, whatever the performance that is used, that will be used to require the code that is used to show that the database in the application will be used in the database management system. In contrast, persistent programming language is the programmer can manipulate persistent data without writing the code that is used to fetch it into the memory. In this section, we describe how the object-oriented programming language such as the C++ and the Java can be used or will be used to make a persistent or to make them persistent programming language. So the C++ and the Java will be extended to make the language at the persistent programming language. These language features allows a programmer to manipulate data directly from the programming language. So whatever the programmer that is used or that whatever the technique that is the programmer used, that is used to manipulate the data directly from the programming language without having to go through a data manipulation language such as the SQL, that is the SQL. They thereby provide tighter integration of the programming languages with the database than, for example, embedded SQL. Then there are certain drawbacks to the persistent programming languages, however, that we must keep in mind when deciding whether to use them. So whatever the drawback, whatever the scenario that will be used, that is to decide whether to use the persistent programming language or whether to use the general programming language. The complexity of the language makes automatic high-level optimization such as to reduce the disk input-output harder. Then a persistence of objects, that is how to make the persistent of objects. So the object-oriented programming languages already have a concept of objects. So whatever the object-oriented language that already have a concept of the objects, a type system to define the object types and the construct to create the object. So whatever the type, whatever the object that will be used, that is used to define the object types and to construct the and that the construct will be used to create the object. However, these objects are transient, that is, they vanish when the program terminates. That is, these objects are vanish or these objects vanish when the program terminates, just as the variable in the Java or C program vanish when the program terminates. If we wish to turn such a language into a database programming language, the first step is to provide a way to make object persistent. The first way that is used to way the object persistent, that is the way to provide a way why the object is persistent with the database object. Several approaches or different approaches have been proposed. So there are different approaches that is used in case of the persistent of an object. First is persistent by the class. That is, the class is used, that is, the class will be used as a persistent object. Then persistent by the creation. So that is the create the object by the persistent value, create the object by the logical persistent values. Then persistent by marking, that is the persistence by marking means mark the object as a persistent after they created, that the persistent by marking. And persistent by reachability, that is whatever the object, whatever the content that will be reached, that will be available to reach the content, that is the persistent by the reachability. So therefore all the object that is referenced, that is the object identifiers, are stored in the root persistent object that are persistent. Next is object identity and the pointer. So how the objects are identified with each other? By using the object identity, that is there will be identifier that will identify the object as a single entity, that is object identity, and the pointers are used whenever there will be creation of the pointer, whenever there will be creation of the pointing object, that is the pointers. So the notion of an object entity has an interesting relation to the pointer in the programming language. A simple way to achieve built-in identity is through the pointer to physical locations in the storage. In particular, in many object-oriented languages such as C++, a transient object identifier is actually an in-memory pointer. However, the association of an object with a physical location in storage may change over the time. So whatever the association, whatever the content that will be used, whatever the object that will be used, that will be changed the physical location in the storage in over that time. So there are various degrees of the performance of the identity. There are multiple degrees of the performance of the identity that is used. First is the inter procedure. That is the same procedure will be followed. That is a different procedure will be followed during the execution of the single procedure. So example of intra program and identity are the local variable within the procedure. So use the local variable, that is the same variable will be used in the procedures. The intra program, that is identity, persists only during the execution of a single program or query. Examples of the intra program identity are global variables. So intra procedure example is simple variable or the single procedure, that is a local variable, and the intra program example is global variable. Then inter program, that is within the program, that identify persists from one program execution to another program, and the pointer to file system on the disk of our inter program or inter program identity, but may change if the way data is stored or the way the data is stored in the file system is changed. Now identity also persists not only among the program execution but also among the structured or structure reorganization of the data. So whatever the reorganization of the data, whatever the structural organization of the data, there will be a persistent data that will be available, that is the identity persists not only among the program execution but also among the structure reorganization of a data. It is a persistent form of the data identity that is required for the object-oriented systems. In persistent extension of the languages such as the C++, object identifiers for the persistent objects are implemented as the persistent pointers. A persistent pointer is a type of pointer that, unlike in memory pointers, remains valid even after the end of the program execution. That is a pointer. Persistent pointer means that the pointer is persistent, that the pointer not change even when the program vanish, even when the end of the program or when the execution of the program is ended, and across some form of data reorganization. A programmer may use a persistent pointer in the same way that she may use an in-memory pointer in a programming language. Then storage and access of persistent object, that is how to store and how to obtain the persistent of the database or persistent objects. Then persistent C++ program or persistent C++ system, that is how the C++ system will be constant, that is a persistent C++ systems. So there are several object-oriented databases that is based on the persistent extensions of the C++, and there are differences among them in terms of the system architecture. That is, there are differences between the C++ program that is used, that is in terms of the system architecture, yet they have many common features in terms of the programming language. And some of the feature or object-related feature of the C++ language supports for the persistent. Some of the feature that is used for the C++ that also support the persistent without changing the language itself. For example, we can declare a class that is a persistent object with the attributes and the method to support persistent. Any other class that should be persistent can be made a subclass of this class and thereby inherit the support for the persistence. The C++ language also let us define standard function names and the operators such as the plus minus, the pointer difference operator, that is the arrow, and the so on according to the type of the operands on which they are applied. This ability is known as the overloading, that is overloading the data, overload the data that is available in the operands. It is used to redefine the operators to behave in the required manner when they are operating on the persistent object. So whatever the object, whatever the operator that is used, whatever the content that will be used, that will be operating on the persistent object. And providing the persistent support, that is the class library, has the benefit of making only minimal change to the C++ necessity. So whatever the minimal change, whatever the change that will be used, that will give the benefit of the making the changes, that is the persistent change, that is the C++ uses the necessary change. However, it has a drawback that the programmer has spent much more time to write a program that handles persistent object. And it is not easy for the programmer to specify the integrity constraint on the schemas or to provide support for declarative querying. So whatever the declarative query, whatever the content that will be used to specify what is a query, what are the types of query, and how to use the query in the database management system. Some persistent C++ implementation supports extension to the C++ syntax to make them or make these tasks easier. So whatever the task, whatever the implementation technique that will be used to make the C++ task easier. Now following expect to be addressed when adding the persistent support to the C++. These are the persistent pointer. So these are the various aspects that is addressed with the persistent objects. First is the persistent pointers, then creation of the persistent objects, then class extents, then relationships, then interface iterator interface, that is the iteration will be maintained in the interface, then transactions, updates, then query language. So these are the various object-oriented methods that will be used in the SQL query languages. Then the persistent Java language, that is persistent Java language. Java system means now the Java language will be persistent, that will be remain constant, that have enormous growth in the usage in the recent year. Now demand for the support for persistent of data in the Java program has grown correspondingly. Initial attempts at creating a standard for persistent in Java were led to the ODMG consortium. So whatever the consortium that is used, that is the ODMG consortium, that is used to make the effort that is used to transfer the design to the Java database object, that is a JDO effort. That is also coordinated by the Sun Microsystem. So that is used with the Sun Microsystem, that is how to use the ODO, how to use the JDO, that is how to make the JDO object. The JDO model for the object persistent in Java program differ from the model for the persistent support in C++ program. And these are the features of the persistent in the JDO, that is the Java database objects. So the first one is persistent by reachability, that is they are persistent by the reachability, that data is reachable to the form, that is data is reachable in the form of the Java database connectivity. Then that is a persistent by the reachability, that are not used or that are not created or that are not explicitly created in a database. Then the bytecode enhancement, that is instead of declaring a class to be persistent in the Java code, classes whose objects made persistent are specified in a configuration file. Then database mapping, that the JDO does not define how the data are stored in the backend database. For example, a common scenario to use to store the database in a relation model, that is the mapping with the database. Then class extend, that is the class will be extended to the another class, that is the inheritance will be made. Then the single reference type, that is the single object will be referred, that is single type will be referred, that is a single reference object. Next is the object relational mapping, that is the next topic, that is how to map the object relational mapping, that is how to map the object relation tables, or that is the object relation databases. So far we have seen two approaches to integrate object-oriented data models and programming languages with database systems. Now object relational mapping. So till now we have done how to integrate the various models, or how to integrate the object-oriented and the programming languages. Now next is the object relational mapping, that provides a third approach to the integration of object-oriented programming language and the database. So the object relational mapping systems are built on the top of a traditional relational database and allows a programmer to define a mapping between the tuples in a database relation. So whatever the tuples, whatever the mapping relation, whatever the content that will be used in the mapping relation, that maps between the tuple in the relational or database relation and the object in the programming language. So whatever the tuples, whatever the relation that is used in the database relation, and whatever the object that is used in the programming languages, they are mapped with each other. So tuples of the database relation, that is the database tables, and the object from the programming languages are mapped with each other. Unlike in persistent programming languages, objects are transient and there is no permanent object identity. So unlike in the persistent programming languages that is used, the objects are the transient and there is no permanent object identity that is available in the object-oriented model. An object that is or the set of the objects. So whatever the content that is the object or either the set of the object that is a combination of various objects can be retrieved based on the selection condition on its attribute. Then object relational mapping system in general is widely used as an hibernate system that provides an object relational mapping to the Java. And the primary goal of the object relational mapping system is to ease the job of programmers who build the applications by providing them an object or by providing them an object relational model. Now object oriented versus object relation, that is what is the main difference between the object oriented model and the object relational model. So till now we have studied about the object relational databases, which are object oriented databases built on the top of the relation model, as well as the object oriented database, which are built around the persistent programming languages, and the object relational mapping system, which can build on the object layer of a top or on the top of the traditional relation system. Each of these approaches, whatever the approach that we have studied, that have a different approach, different market, and their declaration is also different. That is also available in the SQL language that provides a good protection of a data from the programming languages. And the object relational systems aims at making data modeling and querying easier by using the complex data types. And a typical application that also includes the querying of the database system, that also includes the multimedia data. And the declarative language such as the SQL, however, imposes a significant performance penalty for certain types of or for certain kinds of applications that runs in the primary memory and then performs a large number of access to the database. That is whatever the database that is used for defining the database applications. So the persistent programming languages also have some target to achieve the high performance, to give the high performance databases. And object to relational mapping systems allows a programmer to build the application using an object model while using a traditional database system to store the data. So whenever we map the concept, whenever we are doing the mapping, that is the mapping between the object and the relation, that is the object relational mapping system that allows a programmer to build the application. So how to build the application? By using an object model, but while using a traditional database system to store the data. So use a traditional database system, but using the object model to we can say the develop the system. So we can summarize the strength of various kind of database system in this way. There is a relational system, that is simple data type, powerful query language, high protection. Then persistent programming language, that is based on the OTBS, that is a complex data type that integrate with other programming languages and the high performance. Then object relational system, that a complex data type, powerful query language and the high protection. Then object relational mapping system, that have a complex data type integrated with the programming languages, that is designed as a layer on the top of a relational database system. So these are the four various kinds of database system that is available in the programming languages. These description hold in the general, but keep in mind that some database systems blur the boundaries. For example, object-oriented database systems built around a persistent programming language that can be implemented on the top of a relational or the object relational database system. Such system provides a lower performance than the object-oriented database systems. Now, this is the summary of the chapter. The first point says the object relational data model that extends the relational data model by providing a richer type system that including the collection that including the collection types and the object orientation. So whenever we use the object relational data model, that extends the relational data model by providing a richer type system, that is a high type system that includes the collection types and the object orientation. That is how to collect the data, what are the various collection types, and what are the various object orientation features. Then collection types includes nested relations. That is, there will be a collection type that includes the nested relations, set, multisets, and an array, and the object relational model that permits the attribute of a table to be a collection. So that is nested relation, and that contains the object relational model that permits the attribute of a table to be a collection. So there is a object relational data model, there will be a collection that will be used as a nested relation that will be used. Then object oriented or orientation provides inheritance with subtypes and subtables as well as object references. So whatever the inheritance, whatever the subtype, whatever the subtable that is used with the tuple references. The SQL standard includes extensions of the SQL data definition and query languages to deal with the new data type that is used with the object orientation. These include the support for collection valued attributes, inheritance, and the tuple references. That is the collection value attribute, that is the tuple references, and the inheritance that will be used with the traditional databases. And while extending the modeling path. Then object relational database system provides a convenient migration path for the users of a relational database who wish to use the object-oriented feature. Then next point is whenever we use the object relational database system, that is a database system that is based on the object relational model, that also provides a migration path for the users of the relational database that is wish to use the object-oriented features. Then we also talked about the persistent existence or extension to the C++ or Java. So we can use the or we can extend the persistent methods that is also extended with the C++ and Java that also be used to integrate persistent seamlessly and orthogonally with the existing programming language construct and so are easy to use. Then ODMG standard that defines the classes and other constructs for creating and accessing the persistent objects from the C++, while the JDO standard provides equivalent functionality for the Java, that is the ODMG and the JDO. Then next is the object relational mapping system that provides an object view of data that is stored in the database or relational model. So whenever we use the object relational mapping system that provides an object view of data that is already stored in the relational database, and the objects are transient and there is no notion of the persistent object identity. Then objects are created on the demand from the relational data and updates to the data are implemented by updating the relational data. So whenever there will be update on the relational data, that will be updated with the help of the object oriented model, and that will be used to adopt the programming language also, that is used to adopt the general programming language also. Then next is we also discussed the difference between the persistent programming languages, object relation system, and we mentioned the criteria for choosing between that. That is what is the persistent programming language and what is the object relation system that will be used. That is how to create the relation, how to create the table, that is the object relation system that is used in the database systems. And these are the review terms. That is there are different review terms that is used in this chapter. Then these are the practice exercises, that is the exercise of this chapter. This is the creation of the ER diagram that is available in this chapter. Then this is the relation schema, another question, not chapter, another question. Then these are the various we can say the scenario based questions. Then this is the designing question, that is give the SQL command, give the DDL, that is a data definition language. Then write a query to convert data from a schema of the employee to that of the employee A with the array of the collection children by the birthday, array of the scales by the scale type, and the array of the exams by the year. And then writing the SQL statement, that is how to use the SQL statement, write the code for the SQL statement. And these are the various tools that is also used with the ODMG, and these are the bibliographic notes. Now next chapter is chapter number 21 or 23, that is the XML, that is extensible markup language, that is a higher version of the hypertext markup language, that is we can say the latest version or the next version of the HTML, that is a hypertext markup language, that is a XML, that is extensible markup language. As the name advice, extensible means there will be extended form of the markup language. So this I'm going to start in the next class, that is in the Monday's class. So this is enough for today's class because this is a theoretical topic. So that's all for today's session. Thank you so much everyone for listening me, and if there is any doubts, any queries, you can ask the doubts from me. And if there is any advice, you can ask the doubt